In this lecture, we're going to look at elasticity, which is basically the relationship between the change in price and the change in demand. We've looked at each one separately, but one does affect the other. So let's get to it. So far in our lectures, we've been talking about things like the law of demand, the law of supply and demand. And the laws are basically been talking sort of this qualitative aspect. So let's take a look at the law of demand. I mean, the qualitative aspect, this intangible aspect, is basically that when prices go up, demand goes down, and as price goes down, demand goes up. By now, you've got that drilled into your head. But it doesn't really tell us enough. I mean, we understand the basic principles. We understand how consumers' behaviors are going to change based on price, but how much does that behavior change based on price? And that's where elasticity comes in. So in business and economics, elasticity refers to that degree of change in which individuals, consumers, producers change their demand or maybe the amount supplied in response to some sort of change in economic conditions. Now, the predominant use is to assess the change of consumer demand basically on goods or services based on price. So let's take a look at this a little bit more deeply. What we're talking about here is the quantitative aspects of law of demand. We're measuring how strong one variable basically affects the other. We have to put numbers to it because otherwise we could look at a chart like this and we see the price is going down for one item, but there's hardly any change in demand. And when the price goes up, again, there's hardly any change in demand. Is that going to be true for all products? Well, we already see we have two different products here, and we already have two different types of charts. But how much did this one affect versus how much effect was there? That's why we need to put numbers to it. And so the first one we tend to look at is what we call price elasticity of demand. And basically, this is only looking at how the change in price will affect the demand for a product. Now, the actual change is called the product's elasticity. So you hear about elasticity of the item, and we're going to take a look at that a little bit more directly. But I do want to make sure you understand that we're only talking about price. There is income elasticity and a couple other ones, but we usually start with supply. So what are we trying to do? Well, we're trying to look and understand situations such as this. Here we have one item where the price really dropped, but the demand hardly changed at all. And another one where that price dropped the same amount, but the demand really increased. Well, one thing that's going to be important to understand is that we're not going to be talking about raw numbers here. We're going to be talking about percentages. So let's say the price of salt dropped by 30%. We're not going to see a huge change in demand when the price of salt drops by 30%. Versus if houses drop by 30%, we're going to see a significant change in demand. So we already can see that just the product itself is going to make a difference in the elasticity of that product. So this is kind of a general overview. Let's get into some more of the details of this. So the demand curve reflects many of the economic, social, and the psychological forces that affect your demand choices and other buyers' preferences when it comes to demand. You have to understand there's no one rule that I could give you that determines the demand's elasticity. There are, however, some sort of, like you might say, rules of thumb when it comes to the price elasticity of demand. Now, two of the words that we use a lot is whether it's inelastic or is it elastic, this item. And basically what we're talking about is how does the price and demand affect each other. Inelastic items is where we see maybe great changes in price, but not great changes in demand. Think about this. If the price of salt suddenly goes down by 30%, you're probably not going to see that the marketplace is going to have a significant shift in the demand for salt. But if house prices went down by 30%, we would probably see a rather large increase in the demand for new houses. So one is inelastic, one is elastic. And quite often what you hear us talk about is how elastic is the demand. If it's very elastic, we're going to say this. If we say there's not much change, we're going to refer to inelastic. Now, another way I think of this is I think about rubber bands, to be honest. Inelastic to me are these rubber bands you can't stretch very much. I don't really have a very high demand for these. They don't stretch much. I can't use them in many places. Where over here, the ones that I can stretch a great deal, now those I'm in higher demand. because I could use them in multiple places. And so if the price of those goes down, I'm going to buy a lot more of those elastic rubber bands. Now let's take a look at this in sort of a more of a real life situation. So here we are in a grocery store, one shelf full of sodas and candies and nachos, and we got another shelf full of more staple things like cereals and sauces and soups. Our shopper comes along and our shopper says, "Hey, I've come to buy some cans of iced tea." Well, you may have noticed we have cans of soda, but we have no cans of iced tea. We have bottles of iced tea. We have cans of soda, but no cans of iced tea. So one of the first things she has to decide is whether or not she's willing to change her mind. So the availability of close substitutes will affect the elasticity of demand. So in this case, she could either go and buy a bottle of iced tea or a can of soda. So in this case, they're very close substitutes. Whereas if there was no sodas at all, could she, instead of buying a cola, buy a sauce? I don't think many of you are going to pick up a bottle of sauce and just drink it as if it was a soda. So substitutability is pretty far and in between. The more substitutes there are, the more elastic a product is. It's more elastic because I can switch. So the next thing that we might want to look at is the necessity versus a luxury. Well, the truth is, cereal is probably much more of a necessity for this young lady. She has a couple of kids at home. She needs to buy some cereal. She can buy this. She can buy cornflakes. It's a necessity, so she's probably going to be more likely to buy it. Maybe she'll try to decide between which one of these three. Maybe she'll even buy oats, but she can't leave the store without it. Whereas the chocolate over here, well, that's a luxury item, and she could leave the store without it if the prices have gone up too far. In fact, if the price of her cereal went up, which is a necessity, she might not have money for her chocolate. So necessity versus luxury. And then there's something we call the definition of the market. Now, this entire market would be defined as the food market. So food is a broad definition. We don't really substitute food for cars. Last time I looked, we weren't eating cars. So the more broadly defined a market is, will make a big difference on how much substitutability there is. Versus soup. Soup is a narrowly defined market. So she could have this soup, or she could have ramen, or she could have something else. So the more narrowly defined the market is, the easier it is to find substitutes. And finally, there's something called the time horizon. Now this one's a little bit trickier. Can't really use it so well with her. But basically what we know is as prices rise, consumers will change demand if the product is narrowly defined. It lacks substitutability or it's a luxury. So in this case, when she went to the market, let's just say that her chocolate had gone up by, 50 cents. It had gone from $1 to $1.50. Now at first, she might not change too much because she really likes chocolate. But over time, as the cereal prices went up, she started looking at that candy because the candy didn't go up in price. And so she might switch from the chocolate over to the candy. In fact, if the candy prices go up too, after a while, she may just go ahead and say, I'm going to find something else to satisfy my sweet tooth. I'm going to find a sweet cereal, perhaps. So her demand for these items will go down if they're too narrowly defined, if it lacks substitutability, and if it's a luxury good. So these are the three things that are basically sort of a rule of thumb. And if you can remember these, then a lot of the next sort of issues that we talk about will be a lot easier to remember. When I first sort of encountered this particular concept, I gotta tell you, my textbook showed me these kind of formulas and things, and I got a little intimidated in triangles and Q's and P's and D's and X's, and I just wanted to go to the quad and get some chocolate. What I am going to tell you is that a lot of these are math formulas. Some of these are mathematical proofs, and not to worry too much about them. We're going to step through this rather easily and show you what you really need to know. The first thing you need to understand is that the price elasticity of demand is about the relationship between price and demand. Basically, how much does one thing influence the other? So as we used before, we use like salt changing dramatically in price. it didn't really change demand very much. So the price and the demand didn't have a very strong relationship. Whereas the price of houses changed, we saw a pretty strong change in demand. So we see that there's a really strong relationship between these two items. Well, we like to use a simple number to help us understand that. We don't like to guess too much at this. So we're going to calculate these two things by looking at how the change in one affects the change in the other. Now, this is economics, and as I've said before, we're not really hugely into math. Yes, some of the upper ones are, but for this lower level courses, we generally aren't. One thing, though, is that when you're calculating this, you could get a negative number. And you might be noticing that you don't see any negative numbers when you look at elasticity. That's because in economics, we tend to get rid of the negative number. We use something called an absolute value. Basically, because we're looking at the relationship between these things, we're not really caring if it's positive or negative. A -2 or a +2 still shows the same thing to us. So I will say, though, I occasionally see the negative number pop up when I'm listening to a government report or occasionally a business report, but in most cases, when you see elasticity of demand, there's not going to be any negatives. And so let's use our shopper here to kind of understand what's going on. So our shopper normally goes and buys 10 bottles of wine when they're $5 each because she holds a book club, and so she wants to provide some wine for her book club. But recently the price of wine went up pretty dramatically. It went up by $1.25 a bottle. So now the thing is, she can only demand 5 bottles of wine when the price has gone to $6.25. So we'd like to understand the relationship between these two items and how have they affected each other, and can we use that to help predict other demand from other people. So the first thing we're going to want to do is look at basically the change in quantity demanded. So she went from 10 to 5, and so to figure that out, we're just going to divide what she has now by what she used to have. Then we got to figure out the percentage change in price. Now here's the key. We're not going to use this. Nope. We're looking at the change in price. The change is 125. This is where I see students sometimes make a mistake. They use 5 and 6.25, but really it's the change between 5 going up $1.25. And so we make those 2 points, you might want to say. We divide the 2 out and we get a 2. And you're saying, great, we've got 2. What does that mean? Well, basically it just means is that the demand is twice as large of a change than the price is. So great, what does that mean? Well, it basically means that wine is pretty sensitive to price change. In fact, the larger the number in elasticity, the larger the sensitivity to price. And we're going to look at that next so that you have kind of an idea of how the numbers play out. What numbers do you need to pay attention to? So in the last slide, we looked at how to calculate the number for inelasticity or elasticity. Now let's talk about what those numbers actually mean, because the relationship, remember, is what's important. We're using absolute values, so no matter what your outcome is, you're going to use a positive number. So a line quite often works for many people. We'll also graph each one out. Hopefully one of the different ways I show this to you will help you remember it. So the first thing we have to look at is the beginning of the line. The beginning of the line would be 0, and 0 would represent perfect inelasticity. Why? Because as we see, the line is perfectly vertical, meaning that the change in price is not going to shift quantity at all. It means we'll pay whatever price and get the same amount that we usually get. Gasoline tends to be this way, not perfectly, but pretty inelastic, salt, things like this. But we could have a small relative inelasticity, so we're looking at any number that's less than 1, so a 0.5, a 0.25, and that would create a chart that looks like this particular one. Now you notice that we're beginning to lean a little bit, but there's not a whole lot of tilt there. That means that as price changes slightly, quantity is going to have a slight change, but price could change a whole lot and quantity would still only have a slight change. So one doesn't really affect the other that dramatically, but there is some change. And gasoline, probably really I should put that one in here, when over time gasoline is going to see that change. In a short period of time we're going to see more of a zero. Over time we're going to see more of a relative inelasticity. Now the magic number is the number 1, because at 1 we are changing from inelastic to elastic. So the big thing to remember is that anytime you get to the number 1 or higher, we're going to be getting into some sort of elasticity. So we call this unit elasticity because basically for every change in price, unit in price, there's going to be an equal change in quantity. So if price goes up by 10%, quantity is going to change by 10%. Price goes down by 20%, quantity is going to change by 20%. They're exactly together. Very rarely you're going to come out with a unit of 1, but I'm going to tell you sometimes on tests, yeah, it happens. Anything that's going to be over a 1 is going to be relatively elastic, and we should see a line like this. Now, one thing you might notice is that this line is beginning to move upward, and at some point we would actually get to perfect elasticity where we would have a straight line. Now, I'm telling you right now, that is going to be pretty far out because that's the infinity symbol. So what's really good for you to remember is that basically anything between 0 and just before the number 1 is going to be inelastic. Anything from 1 out basically is going to be in your elastic range. So this is one way to look at it. Now, another way that some students really like is if I put it all together on one chart. And here you can really see how that curve goes up like this. So if you can simply remember that 1 is sort of our dividing point, and from 1 and up, we're going to be elastic, and from under 1 and down to 0 is going to be inelastic. You got that basic in your head, you're going to be able to know how elastic something is. So let's just do a quick sort of review of where we're at with elastic and inelastic items. I think examples can really help also. I've talked a lot about salt, but as you look at these items that are coming up, notice that a lot of these may not be things you think about, like insulin or certain prescriptions. People who are diabetics, they don't have really much of a choice. They're going to have to use insulin. And for many of you, you have to use Microsoft Word. This is inelastic. You don't have much choice. If that price goes up, you're going to buy it anyway because your school may require it or your work may require it. Or in order for this to work with that, you're going to have to use this particular software. So we have these factors that influence elasticity, but one of the ones we may not have talked about before is location. So think about location as being something like a hotel. Sometimes people are very surprised to find out that these hotels in these small towns can charge such high rates. Why? Because basically there are no other substitutes. There's no other hotel. It may be a little hotel in a little town, but what other hotel are you going to stay at? Or it could be that they've just got this really great location, right across from the Eiffel Tower in Paris. So location can make a big effect. Now, I also put short run in here because I like to think of gasoline in short run. In the short run, gasoline is inelastic, meaning is that if the price of gasoline goes up, you're not changing your driving habits. But what we will see is that gasoline can change over time, and it can become an elastic item. So as we begin to look at some of these elastic items, notice that some of these items are general categories like clothing, but other items are specific like Kit Kat bars. Well, Kit Kat bar is elastic because there are lots of other Kit Kat bars I could buy. We could just use the term soft drinks because there's lots of soft drinks that we could buy. And so the factors that affect or influence elasticity are basically the same as inelastic, except for the opposite, except for this last one down here. This is necessity or luxury. So if an item is a necessity, it's more than likely going to fall over here into the inelastic, where it's a luxury, it's going to stay in the elastic. Now here's where gasoline has an interesting concept. See, gasoline in the short run isn't going to basically change your demand if there's a change in price. If it goes from $2 to $3, which it has, you're still probably going to be buying about the same amount of gasoline. You're just going to be grumbling. But if gasoline goes from $2 to $5 in the long term, you might start looking for other possible transportation modes. You might start saving for an electric car. You might find out there's a bus. You might look for ride sharing. So gasoline is kind of interesting. In the short run, it's going to be inelastic, but in the long run, it can be elastic. So let's move on to some other topics that we need to look at before we finish up. We're going to take a look at revenue and the elasticity of demand based on revenue. And in case you don't know how to figure out revenue, price times quantity is going to give you revenue. So your neighbor who makes wind chimes at art shows comes over to your house and says, I'd like a little help from you. You're like, okay. She goes, here's what I did last weekend. I sold my wind chimes at $5 and I sold 100 of them. And you said, well, you had a whole revenue of $500 and we can chart it out this way. Now you draw a linear line. Linear simply means straight. And based on the calculations, you know that the point right here, which is what you did, 5 at 100, is going to have a elasticity of 1. So we know that's a unit elasticity. She goes, that's great, but I really want to know about next weekend. What should I do? Well, is next weekend going to be like this weekend? She goes, oh, no. Next weekend, the art show, I'm the only one making wind chimes. Nobody else is going to be there. That's going to change your buyer's behavior because they won't have a substitutability. There'll be no competition. So you say, I think maybe you're going to have a different type of demand curve. I think you're going to have an inelastic demand curve because of the change of basically factors that are there. And so you throw together this little curve, and what you figured out is that if she sells them at $6 instead of $5 based on the curve that you created, she only has to sell 90. Basically, she sells 90 and she's going to make more money than she made before. Now, she's really happy with that. She goes, oh, good. Well, then that's what I'm going to do. I'm going to just start selling them at $6 all the time. And you go, oh, wait. Didn't you say in a couple of weeks you're going to a really big art show? She goes, oh, yeah, I'm going to this really big one. It's a big state one. Are you going to be the only person making wind chimes there? Oh, no. There's going to be several people making wind chimes there. You say, well, that's going to change your demand curve because now there's going to be lots of competition and people can have other substitutes. So you're not going to be inelastic anymore. Now what's going to happen is you're going to have an elastic demand. And so you kind of chart it out this way. And what you show her is that, next weekend you could sell them for $6, and if you sold 90, you make $5.40. But a couple weekends after that, in the big show, if you sell them for $6, you're only going to sell 70. And you'll actually make less money than you made originally when you sold them for $5. And she goes, I don't understand. Well, you say, well, in the last one, the demand curve was, a different shape. And now it's this shape. And when it comes to this shape, what we find is that basically people could substitute things. And so they're not willing to pay the high price that they were before. And so we still have our original box, which is B, because remember, that's where she's starting from. She wants to see how things change. And here's her box for the change. So let's take a look at all three of these together. I think when they're together, sometimes it helps us too. So here are our three boxes and our three basic scenarios, with the middle one being where we started. Now there's a really simple rule of thumb with each one of these, and take a note because it's going to really help you. So if the price elasticity that you calculate is less than 1, price and revenue are going to move in the same direction. That means that as price goes up, your revenue is going to go up. As price goes down, your revenue is going to go down. Where if price elasticity equals 1, which remember I said isn't going to be that common, maybe more in a test, you're not going to see any change really in total revenue no matter what price you sell them at. Now this is not a one slope. We'll talk about that in a second. Just that point is 1. Now, what if we have this very elastic demand curve? Well, then price and revenue are going to move in the opposite direction. So as price goes up, revenue will go down, and as price goes down, revenue will go up. Each one of these is a different scenario, but this basic rule of thumb down here works every time. But I want to take a look at linear lines here. They have sort of a special little twist, you might want to say, versus the curves. Let's take a look at these linear lines. Now, one of the things you might have noticed right away is that there are 3 different elasticities on the same line. That's because the line is straight. One thing we have to remember is that when we're talking about elasticity, it is the ratio of the percentage of change. A slope is going to be the same all the way down, but it's not looking at the percentage of change between 2 variables. So that percentage is going to change all the way up and down this. And we're not going to calculate all the little differences, but let's take a look at some basic rules of thumb. With a linear line, a point where we have higher prices and lower quantity, the demand curve is basically going to be elastic. And we just learned that if the price elasticity is greater than 1, that price and revenue move in opposite directions. So let's see if this is true. We can take a look at the 450 mark here, this A mark, and we can see that we would sell 3 items, and we know how to get total revenue be $13.50. Well, notice price went up to 6. There's your 6. We're only going to sell 1. Price went up, but our revenue went down. We went from $13.50 to only $6. So yes, price and revenue moved in opposite directions when we were in an elasticity. So let's take out elasticity, and inelasticity is basically going to be, I'm going to buy a lot of stuff when the prices are really low. And the rule of thumb here says that price and revenue will move in the same direction. So we're going to take 2 points again, and let's just prove this to ourselves. In this case, we're going to do the 150 mark and the $3 mark. And look at that. When price went up, our revenue went up. They went in the same direction. So with linear, the one thing to remember is that not all of this is going to be a 1. You will have an inelastic and an elastic area. And depending on what you need to do, you might need to calculate it. But the best thing to just remember are these basic rules of thumb that I just told you. And it's still going to make it very easy for you to determine if you're an elastic or an inelastic area by simply looking at the change in revenue versus price. We're going to look at 2 other kind of popular demand curves very quickly. One is the income elasticity of demand. And we already know that income is one of the factors of demand. That generally as your income rises, you're going to have an increase in normal goods. Now just remember that normal goods are those items that you get more of as you have more income. So if you have a car, you might drive more. You might get a second car as your income goes up. And generally these demand curves will shift to the right and they have a positive elasticity when you calculate them. Whereas on the other hand, there are some goods that you might purchase less as income goes up. So in this case, maybe you don't ride the bus so much anymore when your income went up because you could go and get a car now. But if your income goes down, you're going to be back on the bus. And these demand curves generally have negative elasticity. The other one that we can look at is cross price elasticity of demand. And we have to remember again that a change in the price of good can actually change the demand for another good. So let's start with something like peanut butter and jelly. We call this a complementary good because when the price of one changes, it can increase or decrease the demand of the other. So if peanut butter goes on sale, I might want to buy some extra jelly too because the price went down on peanut butter. I can't think of eating peanut butter without jelly. They're complementary of each other, so I'm going to be purchasing both. So you might also think about hot dogs and hot dog buns. If you decide to pick up some extra hot dogs, you're probably going to pick up some extra hot dog buns at the same time. Whereas a substitutable good would be something for me like beef and chicken. So if the price of one goes up, then basically I'm going to want more. So as the cows like to say here, the price of beef went up, I'm going to demand more chicken. So these are just 2 other elasticity of demands, and they both are basically the same as the price elasticity. The difference is what's at the bottom, the change of income for this one. Over here, what we're looking at is the price of the demand of one good versus the change in price of the other good. We've done demand, so let's take a look at how this plays out with elasticity of supply. The big thing here is just to remember that the law of supply, as prices rise, supply rises. So these go in the same direction where the other ones went in the opposite direction. And again, we're measuring the quantity between supply and price. So the formula doesn't look much different. In this case, we're just simply going to have the word supplied there instead of the word demand. So all of this is pretty much the same. But the big difference is that firms have sort of what we say a maximum production level. I have one factory. This is the most that I can produce. And so this is going to change how we look at things slightly, because the result of low supply levels is probably going to be elastic, and at higher levels, we're probably going to be more inelastic because we won't have capacity to produce more. So let's look at how that graphs out. What we do want to remember is that the curve is going to go the opposite direction. So we'll take a situation in which a company is increasing its prices from $3 to $4. And when they increase that price from $3 to $4, we also see an increase in quantity supplied. And so we've got these 2 points. Now, this is going to be inelastic because what we notice here is that the percentage of change at the price level and the percentage of change at the quantity level tells us it's going to be inelastic, because what we know is that the quantity supplied is more of a change than the price change is. Whereas as we move up the curve, we're going to see something opposite. So let's take a look at the company a little later on. They're charging $12 to $15. And so now in this case, what we're going to find is that they're going to go from 500 to 525. And you can see that compared to the other change, we had 100, we're only going to be changing 25 here. And if we look at how we calculate their percentage of change, we also notice that our percentage of change now is higher at price than it is at quantity, and that will show us to be inelastic. So we've got basically the same thing going on that we did before. We're going to be looking at the percentage of change. Let's look at something that we just saw for demand, but we're going to look at how all these different curves look with supply. This isn't going to look too different than what we saw on the demand side, but on the supply side, basically the biggest thing that's going to be happening is that the direction of the curve is going to be different. So we have our inelastic range, just like we did before. Basically, at 0 is your perfectly inelastic, and anything under 1 is going to be inelastic. Then when we get to 1, we'll be at our unelastic. That's our 45-degree angle. And then basically anything that's above 1 is going to be our elastic line. And of course, if we ever got to a straight line, which would be infinity, we would have perfect elasticity. And when we put it all together, it looks very much like the demand one, except for that it's in a different angle. So it's now in a positive slope rather than a downward slope. But the numbers are basically the same. The one thing, remember again, that we are talking about absolute value, not the negative number. We tend to get it away, and we just stick with the absolute value. So if you've got demand down, supply working basically the same way. Earlier in the lecture, I showed a very simple way to calculate elasticity. The problem with that methodology is that when we're using 2 separate numbers on a curve like this, now it could be curved or a straight line, this is a linear one, our elasticity changes. It's also going to be different if we're going upward versus going downward, and that makes it really hard for us to make a lot of decisions about how things are going to move. So what we're going to use is something called the midpoint method to calculate elasticity. What we want to do is basically use sort of an average across the line. So we're going to use basically an initial point and an end point to figure out our elasticity. So we've got our normal curve we have here for demand, and we're going to start with a set of prices, and those sets of prices, of course, would determine what our quantity is. We're going to name those prices P1 and P2, and of course Q2 and Q1. From there, we need to make sure we can figure out what our coordinate points are. Now, I've kind of spelled it out long here just so that you have them. You know, a point is going to be x, y, x, y. And so it's going to be looking for A, that's our point A, is point 1, Q1 and P1. And so that would equal out to that. Now, the formula. Here's the formula for calculating midpoint. Well, one thing I do want you to notice is that it has all those little letters that we have over here. But if I've worked out basically this, which only takes you a second, then it's going to be very easy for me to plug these things in. What I normally do is I make myself a really quick 2 seconds. I write down what each Q1, Q2, P1, P2 is, just to make sure that when I go to fill it into the formula, I haven't put them in the wrong spots. Because if you'll notice, none of the math is really that hard. It's a subtraction, it's a division. So if we go ahead and calculate out the top one, which is what I did first, we've got basically this is the same as this. All I did was take and plug in the numbers because I've got the numbers over here, and that equals to be 0.4. Now I'm going to work out the bottom one. I'm going to do the exact same thing. I've got my numbers right here. I'm going to plug them into the same spots. Make that division, it's 0.4. Well, in case you haven't guessed it by now, when you divide 0.4 by 0.4, you're going to get basically an elasticity of 1. And we know that an elasticity of 1 is a unit elasticity. This is basically the method that many people do, and why we often see when we talk about elasticity that we're not talking about different elasticity if we're moving from this point to this point, or if we move from here to there. We calculate basically a midpoint elasticity. So this is a formula that you need to write down, and I'm basically trying to show you the easiest way to go ahead and calculate that out. Again, pretty simple math, but it is a step-by-step process. Let's pull what we've learned into basically a semi-real situation. So we have this scientist, let's say from UCF, University of Central Florida, and he's come up with a new tomato plant through his crossbreedings that's going to produce 10% more tomatoes per plant. And earlier in our lecture series, we met Farmer Bill, who grows tomatoes. And he's come to us with a very simple question. Am I going to make more or less revenue if I adopt this new tomato plant? Well, we have to know where he starts, and so he's told us that he's making basically $3 per bushel right now, and he can make about 100 bushels per acre. So we can figure out what his current revenue is per acre by simply multiplying 3 times 100. But remember, he's asking us about the future. Should he adopt this new plant or not? Well, we have to graph this out. And one of the first things we're going to do is have the demand curve. Now, the demand curve for tomatoes is pretty well known here in the United States. It's a crop that's been cultivated and eaten for years and years. So we take this information that's already provided to us and we plop that down. We can also now go ahead and chart out basically his information on that, and we can see where he sits on the current line. And of course, we want to go ahead and put in a supply curve. And again, just like the demand curve, the supply curve for tomatoes is pretty well established here in the United States. Now, something you may have noticed is that both of these are an inelastic in their nature, both the supply and the demand. Now, if you don't know what we're talking about or you're not quite certain what that is, go back a few slides and you'll see I've discussed this. I really think it helps students if you would just draw those 5 little charts down so that when you're looking at something, it gives you a quick reference. But he is asking about the future, not about now. So we need to figure this out for him. And what he said is that he's going to be able to get 10% more per plant. And so from 100, 10% more is 110. We chart that out. And what we see is this will be basically his new point. Well, from that, we can draw over and find out what his price is going to be if he's selling 110 bushels on this demand curve. Well, we also now know that it's basically going to be a shift to the right to this for this supply curve. This is really not a very hard question to figure out because now we know it's going to be $2 and he's going to make 110 bushels instead of 100 bushels. And basically the answer is he'll make less. He's going to lose $80 an acre. But I want to take this on a little further because if this was a test question, you could be asked a bunch of other things such as what is the difference in quantity? So we could take our 2 quantity points and we're going to go ahead and use the top half of the formula for elasticity to figure out our difference, our change in percentage change in quantity. Now the truth is that you already know it's 10% because we said that, and in your head you could do it by 10%. But the truth is that these are just easy numbers to sort of learn with. You need to learn how to use the formula so when you get to those harder numbers that aren't so easy just to do in your head, it becomes really familiar and you can double check yourself. You're like, well, I can figure out what that should be. And so if you're getting the right answer from just your mind, then you know that you understand how this works. But we also know that we're going to plot that. And so what about price? What's our difference between 2 to 3? Well, we know that's going to be 0.4, and so we see the change in percentage as that. Well, this tells us a very interesting thing. Remember, we said the percentage change in the quantity supplied is less than the percentage change in price. In this case, 10% versus 40%. We know the results are going to be inelastic. And so we're going to double check ourselves by coming out with our final inelastic number of 0.25. So this is a good example of something that's real life. Should this farmer change or shouldn't this farmer change? Now, if you're looking at this, he might not want to change because basically he's going to lose money per acre. But is that going to be good for us in the long run for growing tomatoes in the United States? We might have to incentivize him in some way to go ahead and change those tomatoes so we could bring down the price of tomatoes across the United States and allow more people to perhaps purchase those tomatoes. So this is just an example of some of the type of things that you might be looking at as you move forward through your lessons. I hope this video was helpful to you. Now you've got the big three under your belt. You've got supply, you've got demand, and you've got elasticity. Once you've got those three, you'll find that you're going to move on to a lot more application things. So as an example, the next lecture in this series is going to be about government policies. As usual, if this was helpful to you, I'd also recommend that you check out the companion site that's going to look at some specific test questions and situations on how to get through those test questions. Elasticity can be a little tricky sometimes in the way that they express it. Meanwhile, till our next lecture, keep learning.